In this video, I'll be discussing motion blur. Motion blur is an effect where an object is moving very quickly and a camera, the shutter speed is not fast enough to actually freeze that motion and capture the motion. What you see, like in this photograph of these birds, is the blurring effect that happens on the wings. Obviously the wings are moving very quickly, and the shutter speed here was slow enough that it could not freeze this high speed action going on. In 3ds Max we have the option to create these effects as well, and let's just like so give this a render. You can see that there's no motion blur on this object. Let's say we want to add motion blur. There's two ways to do that. One is by going into the object properties, and you have a motion blur command here, or section of the object properties. It's disabled right now, even though it's enabled. I'm using none for the motion blur, which is why we don't see any here, so let me just cancel that. What I want to look at first is the camera effects motion blur. So I'm just going to select the camera from the scene here, and if you scroll down you'll have a multi-pass effect option here, and you can enable that, and you have a couple of options here, two of which are depth of field, but we're looking at motion blur here, so you'd select motion blur. Now the neat thing about this is that you can use this preview function to actually see in the viewport what the render is going to look like. So if I hit preview, you can see that now we have motion blur on the parts of this object that are moving. And if I give this a render now, you'll see that we have the motion blur in the actual renders now. You'll also notice that it's rendering several frames instead of just one frame. And what it does is it blurs, or it calculates that motion blur based on this number of passes. If I set this to a lower number, let's just say 6, then what it's going to do is calculate that 6 times. And if you watch when I render this, you can see pass 2 of 6, 3, so it's going to do 6 passes here. Obviously the fewer passes that you have, you get kind of more of a jagged result, less detailed. The more that you have, the smoother the result will be, but of course it's going to take longer to render because, well, it's rendering 24 frames or 24 passes at this point to try and come up with that motion blur. But here you can see the result is a lot smoother. And also the neat thing about using this method is that you can see this in the viewport, which looks very similar to the actual render. It goes away once you do anything other than, once you hit preview, if you click anything, it goes back and erases that out of the viewport. So let's just go back and set this back to 12. The duration setting here, if I give this a preview, think of this as kind of the strength. If I decrease this to, let's say 0.1, you can see it's a very minimal effect here, versus if I increase it to 3, have a much stronger effect. So think of that as the strength of the motion blur. Just reset that back to 1. The bias is, say this wing, whether the motion blur would happen more so on the right side or the left side, top or bottom if you will in this case, of that object. So if I decrease, well, I'll just do this at 0.5, you can see it's kind of in the middle. If I decrease the bias to, let's say 0.1, now what you can notice is that the wing is here and the motion blur is happening more so along the top, whereas if I go to, let's say 0.9, now we have the wing and the motion blur is more along the bottom. That effect happens at the bottom of this particular object. So if you wanted to weight which side of the motion blur happens to an object, that's how you would control that. The normalize weights option, think of that kind of as a smoothing option. What happens is that these passes, a total number of 12 passes in this current setup, these passes, they're blended together with a random weighting to avoid things like streaking. So when this is enabled, it normalizes the weight of that blending process. If this is not enabled, generally you get a sharper result, but a little more grain. Let me see if go ahead and just render this with it off and with it on, and see if we can see the effect. The grainy effect will be probably very subtle, but hopefully it'll be visible. I'll just load this into the RAM player, and then enable weights and give this a render again, and load this into the other side of the RAM player. And I'm not sure if it shows up well in the video, but there's more grain on the side that where we had normalized weights disabled. You can see more grain. Hopefully it shows up in the video. So that's just a way to smooth the effect, or smooth that blending of the passes that this calculates. Down here you have the scanline renderer parameters, where you can just simply disable the filtering or anti-aliasing if you needed to do that. You probably generally wouldn't want to do that unless you were just trying to speed up the rendering process, maybe for some test renders. Then you could disable that just to see how motion blur works, but generally you can get a good preview of it here in the viewport without actually having to render. Okay, so that's the camera effects motion blur with the scanline renderer. Let me just disable this, and of course if I give it a render now, there's no motion blurring. The other option is I can go into the object properties here and use the motion blurring effects for the object itself. Like I said before, it's enabled, but currently I'm not selecting any form of motion blurring. I can select object based or image based, and you can actually think of these as 2D motion blur and 3D motion blur. So if I select object based and give this a render, you can see that it actually didn't do anything. Why is that? Well, if you're using the scanline renderer, there are a couple of options here in the render tab setting. You need to make sure that object motion blur is, you have the apply option enabled for that, and image motion blur. I'll go ahead and apply that because I'll use that next, but I just wanted to show that these are on by default generally, but just in case you didn't get motion blur, that may be a reason why. So now with those enabled, if I give this a render, you can see we have motion blurring again, and I can control that with this actually it's not there. I can control the 3D or the object-based motion blur from the render settings here. Under object motion blur, I can tell it the number of samples that I want it to take, the duration, a higher number of duration. Think of that as the strength, because it's going to sample more frames, so you'll see more of an effect here. And then the samples and the subdivisions basically smooth out the effects that you see here. Naturally, increasing these will increase the render times as well. So now let's switch over to the image-based motion blur. And let me load this into the RAM player. This is the object-based motion blur. And now I'll render the image-based motion blur. And one, you notice that it's a lot faster to render than the object-based. But also it generally provides a smoother result with less render time. Of course, I can increase the sampling of the 3D motion blur or the object-based motion blur to get similar results, but the render times will increase. The downside to image-based motion blur is what I mentioned at the beginning, in that it doesn't work very well for spinning objects or things like that, and I'll show that in more detail. There are some drawbacks to using image-based motion blur, and I'll show those when I start speaking about the mental ray, using this with mental ray motion blur. But the controls here for the image-based motion blur are similar to the object-based motion blur, in that if I wanted a stronger effect, I could increase the duration. Let's just increase that further. can see it taking longer to calculate, and here you can kind of see it breaking down a little bit, not really tracking to the actual motion path here, versus if I was using the 3D motion blur or object-based motion blur. It tends to track a little bit better. Just increase this to 5. It's pretty rough. I'll need to increase the subdivisions and samples to smooth that out, but you can see that it actually moves a little bit better with the path of the wings. But generally you probably wouldn't want your motion blur to be that strong anyway. And so it's more so a subtle effect. If something's moving that fast, you may need or your camera, the shutter speed is really slow, then of course you'll get a lot of motion blur. But as you can see, once you blur out something a lot, it kind of turns transparent anyway. So I think these effects look their best when they're just more so of a subtle effect. Now of course there is another option. Let me just go in and disable motion blur here. If you have a compositing application, you could go in and use a render element, such as, I believe it's called the velocity pass here, and just render this. And what it'll do is give you this color information that you can use in your compositing application to calculate motion blur. Obviously I won't go into the details on that because it's different for every compositing application. So just check if you're using compositing program, just check your instructions with that on how to use this information, this velocity information, to calculate motion blur. Okay, so that's some of the options for creating motion blur using the scanline renderer. So what I'd like to do now is take a look at motion blur with the mental ray renderer. Just load a scene here, a sample scene. Okay, so what I have here is a basic scene set up to test the motion blur with mental ray. And what it is just a sphere that moves. I've got this going 10 frames, 0 through 9, and as you can see, each movement here is marked with a cylinder, kind of just to give me a visual representation of my frames and where the object is. This will come in handy when I'm explaining the offset and things like that of the motion blur. You'll be able to see better what is actually going on. So if I render this the way it is, there's no motion blur in this scene right now, and it should, once it's completed rendering, there'll be no motion blur on the objects. So in the previous discussion, when using the scanline render, what I would do is go in and select my camera and scroll down to the multipass effect and enable that and switch it to motion blur and render away, and it would go through and calculate the different passes, except it would do it very quickly. Here with mental ray, you can see that it's a slow process when you're using this, when you have this motion blur multipass effect enabled. You do not want to use this with mental ray. So think of this as only a scanline option. This is, don't even consider this for mental ray because it's just a different option here. As you can see, it has to render each frame, which is slower in mental ray. So it is doing the motion blur, it does work, but you have to render every frame 12 times, which is not optimal for use with mental ray. So consider that multipass motion blur effect scanline only. So if you can't use the multipass effect, then how do you enable motion blurring with mental ray? Well, there are a couple of options. Just like with the scanline render, you have a couple of options in mental ray. One way is to come to the renderer tab in your render setup screen here, and you have your camera effects rollout. In the camera effects rollout, you have an option for motion blur. Just if I enable that and just leave all the settings at default and give this a render. Let me just cancel that because obviously I left this multipass effect enabled. Again, do not use that with mental ray. Try this again. Okay, so now I have motion blur using mental ray. But notice the render time. That was 1 minute and 44 seconds to calculate that motion blur and render this image. You can increase that speed because what it's doing is this blur all objects is enabled. And in this particular scene, the only thing that's moving is this sphere. So if I wanted to speed up that calculation process, what I could do is uncheck that blur all objects, and now I have to manually tell it which objects to apply motion blur to. And to do that, you use this objects and properties option here. I'm using 3ds Max Design 2010. And with the current UI setup that I have, everything defaults to by layer here instead of by object. So what I want to do is turn that to by object, and I'm going to tell it to enable motion blur on this sphere. Likewise, I'm going to select all these other objects here, go to objects properties, and I'm going to say disabled and set that to none, just to make sure that there's no calculation of motion blur on those objects. Now if I render this again, you can see it goes through, calculates the final gather, and now it's just rendering this at the normal speed instead of actually having to see if there's any movement here and calculate any motion blur. It's a lot faster, and now it's only going to calculate the motion blur on this one object. So making that switch changed the render times from 144 to 117. However, I can do better than that on my render times. I can also switch over to this use fast rasterizer. So when that's enabled, Mental Ray uses this fast rasterizer to generate the first set of rays instead of ray tracing everything, and that can speed up the rendering process. So the last render was 1 minute and 17. I'll switch to the fast rasterizer and give this a render. Okay, so by that switch, now I've decreased the render times to just over 1 minute. If I wanted to do better than that, I could really increase the speed of this by getting rid of these ray trace shadows. On my light sources, all the lights have ray trace shadows here. If I switch this to the mental ray shadow map and give this a render, and by switching that one light to shadow map, since I had the global option enabled, it changed all 3 lights to the mental ray shadow maps. And now it's just going through and calculating the final gather, and now as you can see, the rendering process is a lot faster than if I was using the ray trace shadow option on my light sources. So now I went from 1 minute down to 29 seconds. 1 minute and 2 was the last render, I believe, and now it's 29 seconds just by using that switch. Of course, the shadows are a little bit grainy, so I could increase the quality of the shadows by using more samples, or maybe increasing that map size. I'll just increase the samples to 8 and see what that does to my calculation time here, my render time. So the render time is about the same. I could increase that to a little bit further, maybe 24, to try and smooth this out some more. So the render times went up to 34 seconds. So what I'll do is decrease that back to 16, and instead I'll go into the rasterizer settings. Here, and increase the samples per pixel. Let's try 64. By increasing the samples per pixel, what that does is actually it's smoothing this motion blur. But since the shadows are also motion blurred here, I wanted to increase that to kind of smooth out the motion blur effect. So with those settings, you can see it now that I have a smooth shadow, a pretty good smooth motion blur here, and the render time was 51 seconds. Still far less than almost 1 minute and 50 for the very first render. So, and you can shave that down, the render times, by decreasing the samples per pixel to whatever you need for the motion blur effect here. So whenever you're using this fast rasterizer, just keep in mind that the image sampling rate doesn't work. It doesn't come into play anymore because you're basically sampling per pixel using this value instead. Higher values will, just like increasing the image anti-aliasing here, higher values will slow down the render but give you smoother, cleaner results. So use that accordingly, and only use the higher value as what you need for a particular scene. You don't want to just come in and set that up to 196 and hit render when you can get by with 64 or 36 samples, things like that. Okay, so let's scroll down and look at these motion blur settings. Drag this over. And what we have, the shutter duration, the frames. The default value here is 0.5. And you can think of that as it's set up to where it's going to blur a half a frame before and a half a frame after. So the blur in this current configuration with this scene, if I render this, the motion blur will actually happen cut off right about here and here, a half a frame in front and a half a frame after where this sphere is located. So I'll just give this a render. Okay, and just load this into the RAM player so that we can make a comparison. I'll slide that out of the way for now. And now what I'll do is I'll change that to 1.5. And what that should do is extend this blur out. It's going to look for this calculation 1.5 frames before and 1.5 frames RAM player, so that we can compare the two results. And give this a quick render. Of course, it would help if I switch to the correct viewport. Just lock that down. Alright, and bring it back in the RAM player and load this into channel A. And as you can see, now we have more of the trajectory information in this motion blur. So by increasing the motion segments, you can kind of help the motion blur track the rotation trajectory a little bit better. This next option, the time samples, for the fast rasterizer, that point changes if you're using the ray tracer instead of the fast rasterizer. But what it does is it controls the number of times that a material is shaded during each interval. So here I have the default render or the default value here of this time samples using the fast rasterizer. And here's the render with that. What I'll do is put this in the RAM player for comparison, and then increase this time samples all the way up to 128, which is the highest value you can go to. Render this image again. Okay, now I'll just put this new render in channel A of the RAM player, and as I move around, you don't really see any change in the render here. So what I'll do is I'll come back up to the fast rasterizer setting, and I'll turn that off. And when I do, you notice that this changes to time samples instead of time samples with the fast rasterizer. The interesting thing here is that if I go back to the fast rasterizer, to the ray tracer instead of the fast rasterizer, and change the time samples here, for example, if I change this to 1 or 0, I'll just change it to 1. Then come back to and enable the fast rasterizer, render this image again, and just before I do, you can see that it's changed the time samples here for the fast rasterizer. So now if I add this image to channel A, you can see a definite change there, and for the negative, because it's actually worse than it was. Because I decreased that value, you can see that it's worse. Higher values will give you a more accurate motion blur, especially if the material that you're using that has the motion blur applied to it has strong reflections or refractions. It may require higher samples there. So to get better results for this particular scene, what I'll do is go back to the ray tracer here and increase the time samples. The maximum here is 100. I'll increase that to, let's just say 80. Go back in and enable the fast rasterizer. Here the samples haven't changed, and give this a render. And now you can see I have a much better, much cleaner and smoother result here. I'll just load this into the RAM player. So you can see the before and after on that. So it appears that these two, the time samples and the fast rasterizer and the ray tracer work together, or are linked together. And the interesting thing is, if you come in and let's just say I set that back to 1 and render this again, there really won't be any change in the quality or the look of the render. So at least in 2010, 3ds Max 2010, it looks like that to smooth out that result when using the fast rasterizer motion blur, you have to disable that, come down and adjust the time samples here in the motion blur, then go back and enter, and by adjust it, I mean increase it to get a smoother result. And again, when you increase that, you're going to increase your render time as well. So once you increase that, then you go back, re-enable the fast rasterizer, and to smooth out the result. This doesn't seem to have any effect on the render. It seems to look back to the ray trace version here. And I'm not sure if that's a bug or if that's the way it's supposed to act, to be honest with you. But I'm just showing you how to make that work here in 2010. Okay, so I know that's kind of confusing, switching back and forth like that. So let me just quickly recap what these settings do. The shutter duration, the frames, you can think of that as increasing or decreasing the strength of the motion blur. The shutter offset, if you need to adjust when the motion blur happens relative to the current frame. So if you want the motion blur to push more forward, you would increase that value. If you want it to be more set towards a frame, the previous frame, you would decrease it in the negative range here. The motion segments help create this smooth rotation effect here. So if you have an object that's rotating a lot, you're going to want to increase this motion segment to get that smooth arc motion blur effect. And then when we get to the time samples, that's when it gets kind of hairy, in that when you're using this fast rasterizer, you have to go back and disable that and adjust the time samples here in the motion blur, and then come back in and re-enable the fast rasterizer. Okay, so that's the camera effects motion blur. There's another option for motion blur in Mental Ray. What I'll do is disable this, and I'll go back to the ray tracer here, and what I want to do is hide this object that I'm currently using, this torus, and I'll bring back the sphere. Okay. So one of the other options for motion blur in Mental Ray is a camera shader. We had a camera effect for motion blur, but we also have a camera shader. And part of the production shaders was this new HDR image motion blur option, this new shader, this output shader. So I'll just select that, and then to make changes to this, I need to drag it to the material editor as an instance copy, and make it an instance so that any change here that you make will be updated here on this shader itself. And so what this is a camera lens shader, and it will provide some motion blur in the scene. If I just give this a quick render with the default settings. Okay, so now you can see we have motion blur on this object again, and that's created by this motion blur camera shader. What I want to do is just render this again because I want to point out that this is a post-render effect. So as it's rendering, you won't actually see the motion blur happen. The motion blur will appear in the scene after the render is complete, similar to the way that the glare shader, the camera shaders work. Often that those will be post effects and that they happen after the render is actually completed. So I'm just going to let this go through and render. And now once the render is complete, you'll see that it's still calculating something, and then it applies the motion blur. Now what you have to keep in mind is that this camera shader is image motion blurring. So unlike 3D motion blurring, this may actually it works well for objects like this that are moving by the camera, but if you have something that rotates either on a path or just simply rotates through the scene, such as this let me bring back this torus here, where this torus is rotating around like that as it moves. What you can get, let me just bring up this render. I've went ahead and rendered this out as an animation, and if I play it, it looks okay moving fast, but if you slow that down, you can see that it kind of breaks up, especially like right there. You can see it's okay, and again, if something is moving fast through the scene, you may not notice this as much. Let me turn this on loop. See, it looks fine. So the image motion blurring, while it may not be as accurate as, say, a true 3D motion blur, it may work fine, especially if something is moving fast or if the motion blur effect is subtle on your object here. That's pretty strong, but I could decrease that by decreasing this shutter duration and just put a subtle blur on that, and it would look better. But you know, it's not bad the way it is. There's a couple of other issues that you need to know about with image-based motion blurring versus 3D motion blurring or object motion blurring. Before I get into those, let me just show you real quick. This is the sphere. Let me loop that. Same thing with the good aspect of using the 2D motion blur or the image-based motion blurring is that it's extremely fast versus true 3D motion blurring, which can take quite a bit of time to render. One of the other neat features of this motion blur, image motion blur camera shader is that you can enable this option to blur objects more so as they are closer to the camera, which is kind of what happens if you had an actual camera in the real world. Objects that are closer to the camera get blurred more than objects farther away. So that's a neat function of this particular shader. I'm not going to go in depth with all of the settings here on this image motion blur camera shader because in the help file and the production shader library documentation, Zap has done an excellent job on documenting all of the parameters of this particular shader with images, and basically goes through each one and explains what they all do. So if you need a more in-depth explanation of those, just refer to this production PDF document that ships with 3ds Max. You can also find this online if you need it. So what I'll do now is just look at kind of, I guess you could say, a real-world example of using motion blur here. I'll just start with this. And most of the times when you speak of motion blur, you see it demoed on things like airplanes or helicopters, just because of the spinning rotors on those objects. So what I've got is in this scene is that I've got this helicopter, and as you can see, the rotors are rotating on these. I've got those animated for about 40 frames, it looks like. And in the scene, what I have is one mental ray area spot, and it's set up to use mental ray shadow map so that I can get a quick render time with this, because I don't want, naturally, motion blur can, as I'd said before, really add to your render time. So the key is to keep the render times down. So to set all of this up, I'm going to go back into my camera view here, and instead of using instead of using the ray tracer, I'm just going to use this fast rasterizer. So I'll enable that, come down and enable motion blur, and just give this a quick render to see what I have. Okay, if you notice, I have quite a bit of grain in this first set up here. So what I'll do to reduce that is increase the samples per pixel on my fast rasterizer. So I will increase that to 64 and see what that does. Okay, and that removed a lot of the grain. Also, I'd like to have this effect spread out a little bit farther. So what I'm going to do is change the shutter duration. I'm going to increase that, and again that will make this effect stronger on both sides of the motion of the object here. And since I'm going to spread that out a little bit farther, I know that the noise will be a little bit stronger. So I'm going to increase this a little bit more. I'll just go to 100 for the samples per pixel and see what I have with that. Okay, that looks pretty good. So what I want to do next is maybe give it a few more motion segments, just so that it's not such a hard edge, because that is kind of a rounded area that I want it to flow around, so, or a circular path. So I'm just going to increase the segments, let's say 10. So now with that motion segment set to 10 and this render, you can notice how instead of having that flat area here, it's more curved. It follows the arc a lot better. And so that looks pretty good. So now I think I'm ready for the final render. And what I'll do is just stick a skylight into this scene for some indirect illumination. And I have an HDR image in the background here is what you're seeing, this blue color. Just an HDR image of the sky. So what I'll do is set this skylight up to use the scene environment and go in and enable final gather here under indirect illumination. And I'm going to adjust the raise per points down to 25, and I'm going to set the interpolation to 0 so that I can use the FG brute force mode here, and go ahead and give this a render. Okay, and so there's the completed render. So again, motion blur creates this blurred object effect that you see when something is moving really quickly. And to recap, if you're going to use this with mental ray, it's probably best to use the fast rasterizer for the quickest renders, along with, if you can get by with it, using shadow maps on your lights. In the example of this helicopter, some people will use an alpha mapped material for things like these rotors. Instead of actually rendering the motion blur, they'll create a map of this and use that instead of motion blur for just so that they don't have to wait for the render times, because this is kind of similar to depth of field in that if somebody needs a change, if you're rendering this motion blur effect and you need to change something, well, you have to re-render the image all over again. So it's probably a good idea to do as much of this in post as you can, either by rendering out using the render elements and rendering out a velocity pass and using your compositing program, or as I mentioned before about using an alpha mapped image of motion blur, like for this you would use something like that for this rotor. So if you can use tricks like that, you're probably better off because they're more flexible. But if you have to render out the motion blur, like for example if you had a car moving through your scene and you can't alpha map something like that easily anyway, and you have to render out that motion blur, then use the fast rasterizer because that'll speed up your renders and save you some time. So with that, I conclude the video here on motion blur.